Hi, I am myself Sanjay Kupligadan Sandosh, and today I will be presenting my project on simulating an agriculture drone using the A-star pathfinding algorithm. And in this video, I will walk through my idea, show you why I choose it, and explain the code more detail, and also finally demonstrate how the drone actually navigates around obstacle using A-star algorithm. So coming to my project overview, my project is about simulating a drone flying across a farm field, and the drone starts at the corner, at one corner, and needs to reach a destination, but it has to avoid some obstacle on its way, like trees. And I have created a 200 by 200 meter field in MATLAB, and I added two red rectangular obstacles. The drone starts at 00 and the goal is around 90-80. To handle the path planning, I have used here the A-star algorithm, and nowadays drones are already being used in agriculture for surveying, spraying, and inspection. And with the A-star algorithm, we can plan a smarter path and make more them autonomous. So coming to the code overview, these are the main parts. For that, I will open the MATLAB and I will break down the code in more detail. So I first set the size of the field, that is 200 meter. Then I define the obstacle using this matrix. In this matrix, each row is x, y, width and height. Then I use MATLAB rectangle function to draw them visually in red block. So here that you can see that. Then I define where the drone starts and where it needs to go. For that, I have defined the starting and also the destination at 90-80, and I plot these points, both the points. And here this part is important. I divided the field into 2 by 2 meter cells to form a grid, and this grid will help the SR algorithm figure out which areas are free and which one are blocked. Now I map the obstacle onto the grid like this. So any cells that overlaps with an obstacle become one, and it is considered as a block. Then I convert both the drone's position and goal position to grid coordinates like this, and this is necessary because a star algorithm works with grid indicates, not real world coordinates. Then finally I have called the a star function. Here is that. Then if a path is found, I draw it using a dashed black line. Here is that. And also I animated the drone like this. In this, each step is visualized using green circle, showing how the drone moves across the field. So now let me talk a bit more about what's happening inside the SR algorithm. I use a map called OpenSet to track the nodes that need to be explored. On that, each uh, each node has two values like G score and F score. In this G score, it means how far it is from the start, and the F score, it means how far it could be from the goal. The key part here is heuristic, and also I use Euclidean distance, and this helped the algorithm move in the direction of the goal. For each node, I check its four neighbor up, down, left, and right. If a neighbor isn't an obstacle and has a better score, I update it. Then I reconstruct the path backwards from the goal using the current key equal to current key from current key. And I convert at the end. I convert the grid indicates back into coordinates so I can plot them. So now I will run the simulation. So when I run the simulation, so you can see the drone starts at the green triangle. It avoids a uh, red obstacle blocks, and here each dot shows one step of the drone's journey. The path always avoids the red zone because the algorithm knows those grid cells are blocked. This shows the system is working. The drone finds a valid shortest path from start to goal, even with obstacle in the way. So yeah, wrap it up. This simulation shows how a drone can autonomously navigate using a star inside a grid environment, and I have learned a lot about environment modeling, path planning, and converting real world logic into code. And this same idea could be definitely be applied to real robots, but like using sensor data in place of static obstacles or handling dynamic movement. So this is all I wanted to tell about my project, and thank you for watching this.